And what I'd like you to do on the top of the worksheet, where it asks for your name, go ahead and put your name. Please do this in pencil so when you make mistakes, you can erase it. And your class period is 8, and you can say this is lab worksheet number 6. Okay. All right, so what we're doing in this lab, and I'm going to make a little sketch here, is we're going to be going to a couple of different locations around the room where I've set up some tape on the desks, and they are numbered and labeled like this, in this type of configuration, right? So you may want to even draw this out yourself. And what we're going to be doing, you remember those buggies we used in the lab a little while ago out in the hallway? We're going to use those constant speed buggies, and we're going to use them. They're going to move from position 1 to position 2. We're going to call that a length, L. And then we're rapidly going to turn them so they go from position 2 to position 3. We're going to call that W for width. Okay. And what I'm going to ask you to do first, once I get you in a group, you're going to go to one of these locations. You're going to see a desk has these 3 pieces of tape numbered and labeled. I'm going to ask you to go to that setup. I'm going to give you your group 2 meter sticks. And what I'm going to ask you to do is to measure the length and width between those pieces of tape and record those values here. And notice it's telling you what precision to measure to. I want you to measure out to the 100th of a centimeter. We're just going to start with that. Okay. You're going to record your data here in this table. Remember, the length measurement is from tape 1 to tape 2, basically middle to middle. Estimate where the middle is, and then go from the middle of tape 2 to the middle of tape 3 to give you your width. Okay. Understand? Again, everything off your desk because you're going to be up and moving. When I get you into a group, you'll have to get up and get with those people in your group to do this. Okay. And get around the desk. So each group is going to get 2 of these. And I'm going to have the 4 of you work together. So the 2 of you are going to come over here because you'll see there's tape 1, tape 2, and tape 3. There's 2 meter sticks so you can get going. Let's see. I'm going to have the 4 of you work together. You'll see this is 3, this is 2, and there's 1. Here's your 2 meter sticks. I'm going to have the 4 of you work together, and you'll see over on this desk, here's tape 1, tape 2, and tape 3. So come on over. All right, and I think I'm going to have the 5 of you work together. We're going to go all the way down. Where is it? I know there's 1 here, but it's the one as well. Why don't you come on down here more? And you'll see there's 3, 2, and 1. So here's your 2 meter sticks. Same for 5. Okay? Remember that 1 meter stick is 100 centimeters. So if you need 2 meter sticks to make the measurement, you just take 1 stick, which is 100, and then add on the rest to the next. From the middle of 1 stick to the other. And I'm just going to make up some numbers to use.
I honestly kind of don't do that. I usually do, but I want to. 107. Oh.
Now I'm going to tell you, nobody's life is depending on these measurements that you're making. So just do the best you can. All right. I know you all want to be very particular about it, but in the grand scheme of things, do the best you can. And then you're going to write them down to the precision you see on the screen. Once you have those 2 measurements, you can bring those meter sticks back up to me. And then I'll know that we are ready to go on to the next step. Remember, when you have those two measurements, I'll take your meter sticks so we can go on to the next step because you don't need those anymore. Thank you. Thank you. Thank you. You can. We'll get you back up and moving in a minute. This one will get everybody ready to go. Are you guys done with your meter sticks? Okay, bring those on up because you don't need those anymore. All right. So what we're going to do, and I'll kind of demonstrate it for you. We're going to take those constant velocity buggies, and I'm just going to turn them on. Okay. And you're just going to, when someone in the group is going to have to make some time measurements. All right. One person in the group will need a Chromebook to do that, open up to a stopwatch app, so you can figure that out who's going to do that in a minute. But then one person is going to release it at tape number 1, which is on this table. It's right here. So you can just kind of guesstimate, just be consistent every time you do this. All right. And when you're ready, it's on. You can see it's on, right? It's going. When I set it down, I'm going to tell the person who's timing to start like this. Start. Stop. And as it reaches the third tape, you tell them to stop. And then they reset the timer, and then you do it again. And then you reset the timer, you do it again, and you're going to get your 3 times. Once you have your 3 times, I want the buggy back. And that's it. Then you're just going to wait till everybody's got their times, and then we'll proceed together. Okay? Questions? It's pretty easy. If you get one of these buggies have double switches that can go either way. The way you move the switch will make the wheel turn a certain way. So if you want the buggy to go that way, I have to take the switch and push it in that position. You understand what I mean? Otherwise, if I put it in that position and I want it to go this way, you'll see it's not going to happen. All right, you put these double-sided switches in the direction of which way you want the buggy to go. Okay, so you can get back with your group. I'll come around and give you a buggy to use. Someone in the group needs the stopwatch. Get the stopwatch off your Chromebook. Everybody has one?
Yes, I'm ready.
Remember, you're going to have it started ready to go. Just Google stopwatch and you'll be all set.
I don't want to.
Just let you know right now. It's fine.
That's what I mean. Look at it. So.
Oh, yeah.
You should have hired him before.
What's up?
Yeah, fine. Record my video.
Go.
No, sorry.
Stop.
Was it exactly 4?
It was exactly. It's possible. Surely.
Once you have your 3 times, bring the buggy back up. And then you can sit back down.
Stop.
478?
Thank you, Jacoby. Thank you, Don.
Okay, so then let's start
2, 1, go. Stop.
4.9.
Thank you very much. So everybody should have 3 times. You guys all set? I'll take the buggy back. You got your 3 times. You can put your Chromebook away. You won't need those anymore today. Right. And we all have times that went out to the hundredths place. Okay. So let's just review how we find an average. Again, I'm just trying to review things that you might see on your test. What we have to do to find our average is take those 3 measurements that you have, just add them up, just straight add them. So you can do that with your numbers. Everybody should be doing it because don't rely on your partners to do good calculations. That's a good way to lose a lot of points on a lab, especially if they think they know what they're doing, but they don't. Add them up, get a sum, and then divide it by 3 because there's 3 measurements. Now, you're not writing that whole thing down. Just to review what we do with an average is we always keep the precision of the data. So I need to round my answer to the hundredths place since all my times went to the hundredths place. So my average time with my made up numbers would be 6.53 seconds. Okay. So check with your partners. Make sure you do agree on what those times are and what the average is. Okay. Everybody good? Okay. So you do have out your pencil, your reference table, and your calculator so you can work along here. All right. Now let's go to question 1. We're going to make some changes. Let's change question 1. So it reads, calculate the displacement that the constant velocity car traveled. And according to the precision in the question, we're going to go to the 100th of a centimeter. And then we're going to convert that to meters. Now, let's come back to this picture for a minute. The buggy went from 1 to 2 and then 2 to 3. Where is the displacement in that picture? Where is the displacement in that picture? Really? Yeah, it's an arrow that goes directly from 1 to 3. That is the displacement. This is a right triangle, yes? So there is an easy way for us to calculate that. What equation would we use to calculate the magnitude of that displacement? Right? Yeah, and if you don't remember that, that is on your reference table on the geometry and trigonometry section. Now, these letters obviously don't match the sides of the triangle that we have. The length is side A, the width is side B, and the displacement is side C. So now what you're going to do is your substitution with units. And where am I going to get the values to plug in? Table 1. All right, so you have to now get your values. I'm going to do it with mine. I'm just going to demonstrate what you would do. Make sure you follow every measurement with the centimeters, surround it with a parenthesis, and then the square. Otherwise, you're telling me you have an area that you're adding to another area, which is not correct. And then I want you to go ahead and calculate that displacement on your calculator. And it does tell you that we're going to the 100th of a centimeter. Let me explain why. So that way, if you see it differently on your test today, you'll know what to do. You see that mathematical symbol right there? What's that math operation? What's that called? Addition. Remember, when we add or subtract, we keep the precision of the measurements. These are to the hundredths place, so my answer has to go to the hundredths place. That's how we do addition back from unit 1. So you're going to round to the hundredths place, and that's in centimeters. Okay, round your answer. Check with your partners. Make sure you agree. Are you rounding the same way? Are you getting the same thing? If not, fix it. Manure, go ahead and move down. That way you're still with your group. Okay. Everybody all set? Okay, now we want to convert it to meters. So when we convert, remember we're getting rid of the prefix centi. So you got to go to your reference table, look up what the power of 10 is. That goes with centi. And what power of 10, according to your reference table, is centi? Caroline? Yep, so we would write that as 1 times 10 to the negative 2. The centis cancel. And now you just go to your calculator, multiply them out, get an answer. You're going to keep all the digits. You don't drop them because the 100th of a centimeter is the 10,000th of a meter. So that is half of the answer I need. It's half the answer I need. It's just half of it. Because if you remember, a displacement has a second part to its answer. What's the second thing I need in order to get a displacement? This is its magnitude. What else do I need? Uh-oh. Don't make me nervous about what you're going to see on your test next period. What's the other thing you need? A direction. Okay, that's the angle theta. Now, let's come back to this triangle. I'm doing it a little differently than how we learned in class. I just want you to find the inside angle with the horizontal this time. That's going to be the direction we're looking for, that angle right there. Okay. Do you remember how to find that angle? What equation are we going to write? I'm sorry? Inverse tangent of the, when you do tan in SOHCAHTOA, what are the two sides divided by each other? Opposite and adjacent. Let's start with that. Opposite over adjacent. Now, let's see if we can change them to the variables that are here. Length and width. Which one's the opposite side of that angle? The length or the width? The width. All right. So that would be the width over the length. That's what we're going to do. So that's the equation we're going to use, that the angle is the inverse tan of opposite over adjacent. Now we're going to go ahead and do our substitution with the units. We already said the opposite side is the width. We're going to get that value back from our first data table. Make sure you include the unit. And then you can get your length value, the adjacent side, including the unit. Those centimeters cancel out. And you're going to get that angle to the nearest degree. Remember, we always do these to the nearest degree. So go ahead, do it on your calculator with your numbers. Your answer is going to be different than mine because I am not using your data. I'm just using completely made up numbers. And you round to the nearest degree. So check with your partners. Make sure you agree. Do you get the same direction? Right.
You put your, like, did you put the negative? Did you put second, yeah?
Yeah.
Okay.
Are you in scientific mode? Yeah, get out of scientific mode. Yeah, you don't need scientific mode for this. You probably had an E on the far right. Yeah, okay. All right, can we go to the next question? Número dos. Now I want the distance. All right, so look back at that picture. The car went from 1 to 2 to 3. So what should we do to come up with this distance? What is it, Ashley? add them. So if I were to write that as an equation, remember distance is just d without the arrow. I have to add the length to the width. So that would be the equation that I'm writing to solve this question. We always start with an equation, and that's my equation. Now you're going to do your substitution with your units. You're going to get your values from your first table. Make sure you follow that with the unit of centimeters from the column heading. Then you're going to get an answer in centimeters. Remember, since we're adding, we're going to keep the precision. So this will also go out to the 100th of a centimeter. And then notice it wants you to convert that to meters. So we're going to do this the same way we did previously. Centi in the bottom, the 1 times 10 to the negative 2 in the numerator. So the centis will cancel. And then you get your final answer for your distance. Now, you should not be getting 1.6918 meters, right? You got to use your numbers, not mine. Check with your partners. Make sure you get the same answers as your partners. Are we good? Can we go on? All right, number 3. Now we're going to do guess method. I want you now to calculate the average speed of this constant velocity car. What things do you need in order to calculate an average speed? What 2 things do you need, Anson? You need a distance and a time. Where are you going to get your distance from? Yeah, your answer to the previous question in meters. Where are you going to get your time? Raiden? Yeah, the average time from the data table on the front, whatever your group's average was. And that's in seconds. Now, unknown is speed, which is just V. Now you have to give me the equation we use to solve for an average speed. It is on your reference table if you want to look there to remind yourself what is the equation we're going to use to get that speed. Caroline? That's right. V equals D divided by T. Let's now do our substitution with our units. And then you're going to solve it, getting an answer with proper units and sig figs. And if I just review the rules for sig figs, these both have decimal places or decimal points that are clearly visible. So I go from the Pacific to the Atlantic, left to right. 1, 2, 3, 4, 5. I have 5 in the top. 1, 2, 3 in the bottom. So my answer needs to be rounded to 3 sig figs. You have to use your values to figure out how many sig figs you're going to get. And then you can, of course, I'll ask you to check your answer with your partners to make sure you all agree on what the answer is for your group. Okay. Are we good? Good, good, good. Okay, let's go to 4. Number 4, I now want you to find average velocity. Calculate that average velocity. What measurements do you need to know in order to calculate a velocity? Danny, what do you need to know to find a velocity? Your reference table can help you. No, there you have an equation on page 6, right? You're looking at page 6. Velocity, the average velocity. Okay, so what are the two measurements we need in order to find the velocity? Can you name them?
No.
Aiden, can you help him out? What things do you need to get velocity? You need the displacement and the time. Where are we going to find our answer for the displacement? Miranda, where am I going to get my displacement from? Yes, number 1. And the displacement has both a magnitude and a direction. So let me show you how you're going to write that. You're going to take the magnitude, whatever yours is, follow it with the comma, and then include the direction with it, which was the angle measure. The time, is it the same time we used in the last one? Yeah. It's the same amount of time. That doesn't change. Now, velocity is V with the arrow. And as I've heard already, the equation for velocity is the displacement over the time. So now we're going to do our substitution with our units. We're going to plug the whole thing in, 1.3339 meters for me, comma 19 degrees, divided by the 6.53 seconds. Now, before you go to your calculator, let me just explain. You do not take the angle measure and divide by the time. You only take the magnitude of the displacement and divide it by the time. So you're going to go ahead and do that again with correct units and significant digits. But then you have to include a direction with velocity, because what type of measurement is velocity? It's a vector. Now, the direction of your displacement is what determines the direction of your velocity. So since the displacement was at 19 degrees, the velocity is also at 19 degrees for me. Whatever yours is, you just be consistent. The direction of the displacement determines the direction of the velocity. So once you've got yours calculated out, check with your partners, make sure you agree on what the answer should be, and then we'll talk about question 5. Yes, Ashley? So if the car had just gone from 1 to 2, there was nothing else, then you could say right, or you could say 0 degrees. But because it's going in 2 different directions, now you're going to need an angle. Okay. Okay. Anyone need more time for number 4? Okay, let me walk you through number 5. Number 5 says, by definition, what's the difference between an average speed and an average velocity? Now, I'm going to tell you there are 2 differences between them. What you're going to have to do is figure out what those 2 differences are. I'm not going to tell you what they are, but I'm going to give you a hint. I'm going to give you a big hint. The first difference comes from your givens. Look at the givens. Finding the speed used one set of givens, finding the velocity used a different set. There's one of the differences. You need to be able to tell me what is different. Secondly, look at your answers. The other one can be observed in the answers. You see what I mean? There's a difference here. And I'm not talking about the numbers. There's something else. That gives you the two differences between a speed and a velocity. Okay, do you follow what I'm saying? Go ahead, answer that. Get those two things down. Confer with your group. Make sure you agree what those two differences are. Get them down. And then the lab is done.